Speaking of experimentation and research, let's jump to that chapter 3 that you mentioned earlier, the fun one. I mean, there's lots of fun chapters, but chapter 3 is a particularly good one. And in it, you present your comprehensive framework for AI evaluation. So you emphasize that accuracy alone isn't enough. And so you introduce multiple metrics across different task types: retrieval, classification, generation, and you stress the importance of reproducible experiments. You conclude the chapter by noting, from now on, we will be incorporating evaluation language into every case study. So then throughout the rest of the book, you have these fantastic detailed case studies that build on each other. And you use this common evaluation language that you introduce in chapter 3 throughout, which is brilliant. So when you organize this evaluation by task buckets: generation, multiple choice, embedding, classification, why is that separation so critical?
Yeah. So the split is usually of the types of LLM tasks. There's generative and understanding, and then under generative, there's multiple choice and free text. Meaning, it's basically like auto encoding versus autoregressive. Is how I try to think about that analogously. Meaning, if you're talking to a chatbot or an agent, which is just a chatbot with tools, you're asking it either to produce a paragraph, a sentence, several paragraphs, whatever, free text, or you're asking it to pick from a set of options. Should I proceed? Yes or no? Is this good enough to post on LinkedIn? Yes or no? That's multiple choice. I'm basically collapsing the entirety of this deep learning architecture into a binary classification task. So versus understanding tasks, which are embeddings and classifications, which are similar to multiple choice, but just with a different architecture. Each one of those has their own suite of metrics, because how I evaluate a child's essay on A Catcher in the Rye is going to be different than how I evaluate the embeddings that this embedding model is producing. They're just not the same task. They're not built for the same thing. They're all in LLMs. OpenAI embeddings are produced by LLMs. Classification models are run for the most part by LLMs. So the evaluation is less on the model. It's more on the task that you're trying to perform. And whether you're performing classification through any kind of architecture, my book from 10 years ago, Principles of Data Science, talked about accuracy, precision, recall, sensitivity versus specificity. I also talk about that in my book from 2 months ago, Agentic AI. It's the same classification that I'm asking an agent to do. It's the same task. It's just a different model is now doing it. So evaluation is tricky. It's the longest video I ever wrote or made. It was like 9-10 hours on the O'Reilly platform was evaluations, because there is no one size fits all. It's, what are you doing? I'm now going to walk through 20 case studies that are all very different from each other, all with different metrics.
Yeah, and so to dig into this a little bit more, you mentioned there are all these different kinds of metrics for evaluating performance. So I already said in a question a few minutes ago how accuracy isn't enough. In your book, you emphasize how using precision, recall, and for some, where you're trying to rank results, something like mean reciprocal rank, MRR, using those metrics together, because each exposes different failure modes of a model. Do you want to tell us a bit more about that?
Yeah. So precision recall is probably the more, I would say, usable metrics across for most people. Meaning, I'll say it this way: if you ask an LLM, you give it a LinkedIn post, and you say, "Is this going to get a lot of engagement on LinkedIn?" And it says yes. Okay, great. You post it. It doesn't get a lot of engagement. That model had a false positive. It told you yes, but really it was no. When you care about false positives a lot, when they are expensive to you, you care about precision. Precision is the measurement of all the times the model said yes, how often can you trust it? So when the model says yes, go ahead, how often is it correct in saying yes? That's precision. So when you care about false positives, precision is your metric. Recall is kind of the opposite. Recall is, of all the times it should have said yes, how many times did it? So if false negatives are expensive to you, recall is the metric you care about. Because if the thing says, this is a terrible LinkedIn post, but you post it anyways, and it gets a lot of engagement, that's a false negative. It didn't want you to post that. And recall is a measurement, among other things. A recall is effectively a measurement of how many false negatives that you're seeing out of this system. So, and that was a pretty, dense explanation for two, honestly, one of the simplest metrics in machine learning. And it kind of goes to show that the conversation around evaluation is not always as simple as, here's the fraction that you care about. It's, no, before we get to math, what do you, the human, care about? What's expensive to you? If you say this factory part off the line is good, but it's not good, is a plane going down or is someone's light going to break? How expensive is a false positive to you? If it's expensive, precision is the thing you need to look at. Recall shouldn't matter as much. I'll happily throw a part away on accident. At least if I know everything off the line is going to be right, precision matters the most. So it always comes down to not just the task, but even the risks of failing that task.